kids, so far we have seen in current electricity the material science behind the generation of current, or physics behind the generation of current. What all factors will make the current to flow? Okay, then the average velocity of charge carriers, which is nothing but drift velocity, the relation of drift velocity with the current. Okay, then current density, vector form and scalar form of Ohm's law. Then about resistance in a conductor, what all factors will decide the resistance and its resistivity, effect of temperature in deciding the resistance. So all this basic theory we have studied. Now from today's topic onwards, we are getting into the circuit level questions, or circuit level problems, or circuit level analysis of the chapter. Now from here onwards, we have to train ourselves to apply the knowledge, to apply the skills, or apply the techniques which we learn day by day into solving circuits. So for example, when I get a circuit, the way I solve will be different than you solve. Okay, so between you students also, you may have different ways to solve a circuit. So all it depends on the person. If someone is very fluent, someone is very skilled in solving circuits, he or she will be finding it easy. Okay, so the main thing here is, here onwards, whatever we study here, we will have to take new circuits, and we have to practice it. Okay, this is the prerequisite. Okay, this attitude or this decision is a prerequisite to deal this part. Okay, so combination of resistors, we will start with the combination of resistors. So each day you can solve some circuits on your own from any books, once if you learn one by one. Okay, so here combination of resistors. So number one is series combination. Then we will study parallel combination, series combination and parallel combination. So first we will see series combination. If two resistances are connected in series, what will be the effect? So first we will see series combination. Okay, so three resistors. I take three resistors, R1, R2, R3. They are connected in series. Now we connect them to a battery. Okay, so the battery's voltage or potential difference is nothing but V. So if we connect like this, this is a closed circuit. Okay, so for current to generate, for current to flow in a circuit, there should be a closed circuit. It should be closed, then only current will flow. Okay, so we will see. So here current will be flowing, I, current will be flowing. So what will be the current here? Current through R1, current through R2, current through R3, all will be same, because this is series current, or same current is flowing through the circuit. So current through R1, R2, R3 all will be same, but voltage across R1 will be V1, this will be V2, and this will be V3. So we can write like V1 is equal to IR1, V2 is equal to IR2, V2 is equal to IR2, and V3 is equal to IR3. Okay. Now this voltage V will be divided among R1, R2, R3. We can write. So I can write V is equal to V1 plus V2 plus V3. So whatever potential difference we apply, this potential difference will be divided among the resistance. No, need not be equally. If the resistances are different, then which one has more resistance, that will consume more voltage because of this relation. Now suppose if we consider this resistance, what is the equivalent resistance of this? If we consider like if three resistances R1, R2, R3, if we replace with a single resistance R equivalent, then what will be this resistance? The R1, R2, R3 putting together, what will be the value? That is what? Equivalent resistance. So if we consider like this, we can redraw the circuit in this way, like this. Like this we can draw. So this is nothing but R equivalent, this is V, this is I. Okay, so V is equal to V1 plus V2 plus V3. So I into R equivalent, this is what is V is, correct or what? If we write the equation here, V is equal to I into R equivalent. Okay, so I into R equivalent is equal to V1 plus V2 plus V3. We will replace with the IR1 plus IR2 plus IR3. So this I, if I cancel, I will be getting R equivalent is equal to R1 plus R2 plus R3. So if we connect resistances in series, we will be getting, we can add those resistances to get the equivalent resistance. Note it down. Suppose if we connect R1, R, likewise we have connected N Rs. This is 1, 2, 3 up to N. If we connect like this, similar resistances if we connect in series, N number of resistances if we connect in series, then R equivalent is equal to what? R plus, likewise up to NR we will add. So R equivalent is nothing but N into R. Okay, equivalent resistance is nothing but N into R if we connect equal resistances in series. Okay, so here in series connection, current is same. Current is stream through all resistances. In what situation? In series connection. But voltage is divided among the resistances. Voltage is divided among the resistances. I'm telling you a small trick. Suppose if we get two resistances like this, if this is V, this is R1, this is R2. Okay, what is the voltage across R1? So simple trick is this resistance, this voltage V into R1 divided by R1 plus R2. Voltage across R2 is nothing but V, common voltage, into R2 divided by R1 plus R2. Okay, note down this trick if two resistances are there. If three resistances are there, you can add that resistance also in the denominator. You can do accordingly. This is called voltage division rule. Voltage division rule. So whenever we get a situation where if we apply voltage division rule, it will be easy to solve the problem, then directly apply it and get the answer. Parallel combination. Okay, suppose three resistances R1, R2 and R3. They are connected like this. This is called a parallel combination. Now if this parallel combination is connected to a voltage source or a battery, okay, current I will be flowing like this. Now once the current reaches here, current will be divided. So here if this is P, since this is parallel, R1, R2, R3 and this voltage all are in parallel. So we know among parallel branches the voltage will be same. Potential difference across the parallel branches will be same. So this is going to be V same. This is also V and this is also V. All the branches will have same voltages. All the branches will have same voltages. Only the current will vary. Correct or what? So here I is equal to I1 plus I2 plus I3. If we replace this circuit into an equivalent resistance, if we name it as R equivalent, and if this is V and this is I, then we can write like I is equal to V by R equivalent. V by R equivalent. I1 is the current that is flowing through this branch I1. This one is I2. The current that is flowing through resistance R2 is I2. Through R3 this is going to be I3. Correct? So here I can write I1 is equal to, the voltage across this resistance is V. I is equal to V by R, right? V is equal to IR. So if I1 is equal to V by R1, V by R1, I2 is equal to V by R2 and I3 is equal to V by R3. Is it correct? Now substituting in this equation, I can write V by R equivalent is equal to I1 V by R1 plus I2 V by R2 plus I3 is V by R3. Cancelling V, what we get? 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, note it down. Suppose if two resistances are connected like this, R1, R2, then R equivalent can be directly write like R1, R2 divided by R1 plus R2. Just like from the previous formula, 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So if we solve this, we will be getting R2 plus R1 divided by R1 R2. So if we take the reciprocal, we will be getting this formula. So if we get two resistances, directly apply this formula and get the answer. Suppose if we get n number of resistances, n number of equal resistances like this. This is 1, 2 up to n. Then R equivalent can be written like R. These are all same value of resistances. If this is R, then R by N. In series it was R equivalent is equal to NR. In series resistance R equivalent was NR, but in this case R equivalent is equal to R by N. Okay. We will do a problem. Okay, suppose if we just simply I am mentioning, if this is 10 ohm and another is also 10 ohm, then R by N here 2, so 10 by 2 we get 5 ohm. Likewise we can find the answer easily. Okay, we'll do some problems now. Number 1. We'll start from simple problems, then we will move to, we will slowly increase the complexities and we will do. Okay, so find current and potential drop in each resistances. Okay, you might have got the answer. Okay, just to start with, we are doing this. So current I is equal to, this is V. So what is R equivalent? R equivalent is equal to R1 plus R2. This is series connection. So 2 ohm plus 4 ohm we get 6 ohm. So what about current? So this is series connection. Series connection means the current will be same across. So this is going to be I everywhere, same current. Okay. So I is equal to 12 divided by or V divided by R equivalent. So V is equal to 12, R equivalent is equal to 6. So this is going to be 2 ampere. So 2 ampere current will be flowing through this. Okay. 2 ampere current. What about the voltage across 2 ohm? V is equal to I into R. So V across 2 ohm is equal to, current is what? 2 and voltage resistance is 2. So this is going to be 4 volt. Same way voltage across 4 ohm. Voltage across 4 ohm is nothing but the current flowing through the resistance is 2 into the resistance is 4. So this is going to be 8 volt. 8 volt. So here this is 12 volt. How much is the drop at 2 ohm? This is going to be 4 volt drop. What about here? This is going to be 8 volt. So 8 plus 4 is equal to 12. So this 12 volt is distributed here and here. Resistance will eat the voltage. Clear or what? This is how. Simple question just to understand the basics. Now if you want, you need not waste this much time here. Okay, simply we can do this very easily without doing all this. Okay, we know, we have seen voltage division rule. Voltage division rule is what? V across R1 is equal to VR1 by R1 plus R2. VR2 is equal to VR2 divided by V into R2. VR2 means voltage across R2 is nothing but common voltage into, or common potential difference into resistance divided by total resistance. So apply this. I am writing this formula just for your convenience. If you are starting from the beginning, just if I go slow, you will understand. Otherwise, directly don't write all this, just smash the formulas and get the answer. Write the things fatafat and go to the options. So just like this, 12 into R1 is 2 divided by 4 plus 2 is 6. So this is 2 going to be 4 volt. This one 12 into 4 divided by 4 plus 2 is 6. This is 2. This is going to be 8 volt. Got. So this is 4 volt and this is 8 volt. How much is the current passing through this? Okay. I is equal to V by R. I is equal to V by R. So 4 by 2 is 2 ampere. This is 2 ampere will be going through all this. Need not find any other thing. This is the simplest way, time saving method to do this problem. Instead of going through all the things, just apply voltage division rule and get the answer as fast as possible. So when you get these kind of questions in your board exam, write all the steps and do it just in such a way that your teachers will understand all the steps, so that you will get marks. But if for Neet or JEE, take the short method. Okay, next question. Okay, find the current and potential drop in each resistor. Okay, and find the current drawn from the cell. Find the current drawn from the cell. Okay, start doing. So what they are asking, find the current through this branch. How much current is drawn from the cell? What is the voltage across all these? This is what the question is. Okay, so direct method, just to find R equivalent. Finding R equivalent is how much? R1 R2 by R1 plus R2. Okay, 6 into 3 by 6 plus 3. This is going to be 2 ohm. Now this circuit can be replaced like this. This is 2 ohm, this is 12 volt. Then what will be the current flowing through this? I is equal to V divided by R equivalent. So V is equal to 12 divided by R equivalent is going to be 2. This is going to be 6 ampere. So 6 ampere current will be flowing through this. Correct or what? Six ampere current will be flowing till this. Now from there current will divide. So how to find the ratio of current? So take 2 minutes, try to find, then verify your answer. Okay, so maybe you might have done using different method, any method. I will be solving in different methods also. One method is, if this is 12 volt, all these are parallel. This one, all these are parallel. So this is 12 volt, again this also 12 volt. Why I am putting plus, minus and all? You need not consider that now. We will discuss about it in the further topics. Okay. So we have exclusive circuit solving sessions, so that time I will explain all this, why we put this plus, minus and all. Okay, so when we put 12 volt here, this is I is equal to, what will happen? I is equal to 12 divided by 3. Suppose if we take this as, if this as I1 and this as I2, then I can write I1 is equal to V by R, 12 divided by, or V1 divided by R1, 12 divided by 6, we get 2 ampere. So I2 will be obviously 4 ampere. Okay, so V2 by R2. So since this is parallel combination, need not write any numbering and all. So this is going to be 12 divided by 3. So this is going to be 4 ampere. So this is how we can find the current across all the branches, voltage across all the branches. Now see students, we will study some tricks here. I1 is equal to V by R1, I1, V by R1. I2 is equal to V by R2. Clear? Now I1 by I2 is equal to V by R1 by V by R2. So this V get cancelled off. We can write I1, the ratio of I1 is to I2 is equal to 1 by R1 is to 1 by R2. I1 is to I1, I1 is to I2 is equal to 1 by R1 is to 1 by R2. If we get only 2 branches, then we can apply current division rule just like a voltage division rule. I will tell that also. But if we get more branches, then we will use this technique. So this is also important. And one more thing is I1 plus I2 is equal to I, that is total branch. So remember this. Okay, I1 is to I2. Suppose if 3 branches are there, I1 is to I2 is equal to 1 by R1 is to 1 by R2, sorry, is to I3. If we get like that, 1 by R3. See, I1 is to I2 is to I3 is equal to 1 by R1 is to 1 by R2 is equal to 1 by R3. So if 2 branches are there, we have an easy method. But if two or more branches, more than 2 branches are there, 3 branches, 4 branches, then if we are not in a position to find the voltages, then this trick will save us, will help us to find the answer. Okay, so note down. If 2 branches are there, that is current division rule. Current division rule is I1 is equal to, if we know this current I, then I into R2. If we need to find this current, take this resistance R2, divide by R1 plus R2. I2 is equal to I into R1 divided by R1 plus R2. Opposite branch resistance divided by total resistance. Actually this is just like a voltage division rule. Voltage division rule, V into R1 we took, current we are taking the opposite branch. From the ratio of current, ratio I1 is to I2 is equal to 1 by R1 is to 1 by R2. From there only we are getting all this. But when if we have 2 branches, directly do like this and we'll get the answer easily. Or otherwise we will have to take the ratio and solve the questions. Note it down. We'll do this question. Six ampere, 3 ohm, 6 ohm, I1, I2. Okay, leave it. Need not draw this. Okay. This is the data given in the question. It doesn't mean that this is not connected. This is connected, but only this part of the circuit is given in the question. The only hint for us is 6 ampere is coming. If one voltage has shown like this, then we will be able to put those voltages here and we will be able to understand the current values. But here that voltage part is not given. Only detail they have given is this 6 ampere is coming. So how to find this? So we know the ratio I1 is to I2 is equal to 1 by R1 is to 1 by R2. Okay, this ratio we know. Another ratio which we know is ratio I1 plus I2 is equal to 6 ampere. This also we know, or I. Okay, right. So I1 is to I2 is equal to 1 by 3 is to 1 by 6. Now how to make it into a proper ratio? Multiply with the biggest number. So we will be getting I1 is to I2 is equal to, if we multiply with the 6, this will become 2 and this will become 1. Right? So I1 is to I2 is equal to 2 is to 1. Now how to find I1? How to find I1? So total is 6 ampere. So 6 ampere means I1 is 2 ratio is there, divide by sum of these two, 2 by 3. Correct or what? How to find a part from the ratio? The ratio divide by total of the ratio into the total quantity that is coming. So here I1 is to I2. So I1's part is 2. That 2 we write here. Sum of these two, 3, into this current if we write, then we will be getting 4 ampere. Clear or what? Same way I2. Its part is 1. So 1 divided by total 3. This is the share of I2. Of what? Of 6 ampere. So 6. This is going to be 2 ampere. So this is going to be 4 ampere. This is going to be 2 ampere. Clear? Hope you understood. If we have the ratio, take the sum of it. Take the sum of it. How much is one part? That divide by sum into, this is the part of I1. This is the part of I1. Into the total, we will get its complete part. This is going to be 4 ampere. This is going to be 2 ampere. So totally 6 ampere. Right. So this is how we need to find through ratio. Okay, through ratio, this is how we can find. Then how to find easily? Through current division rule. Current division rule. Using current division rule, again we can find. If two resistances are, it is easy. So I1, this one, is equal to I into R2 divided by R1 plus R2, right? And I2 is equal to I into R1 divided by R1 plus R2. I2 R1, I2 R1, I1 R2, this one, okay, opposite. Okay, fine. So I1 is equal to 6 into R2 is here 6 divided by 6 plus 3 is 9. So here 2, here 3, here if we cut 2, this is going to be 4 ampere. We get 4 ampere. I2 is equal to 6. This is what we are going to find. So 6 into this resistance, 6 into 3 divided by what? 6 plus 3, 9. Cut 3, cut 2. This is going to be 2 ampere. So whatever answer we got, 4 ampere, 2 ampere, we get this current division rule also. But you should have the knowledge of that method also, ratio method also, because if we get 3 or more resistances, then that will be the technique to use here. Take another question. Ampere is coming. 1 ohm, 2 ohm, 3 ohm. So this is I1, this is I2, this is I3. So find I1, I2, I3. Find I1, I2, I3. I1, I2, I3. Find. Okay, so I use the method I1 is to, I2 is to, I3 is equal to 1 by 1 is to 1 by 2 is to 1 by 3. 1 by R1 is to 1 by R2 is equal to 1 by R3. Okay, this is how now I1 is to I2 is equal to 1 by R1 is to 1 by R3. So I1 I have taken R1, I2 I have taken R2, this is R3. So I put the, I am just naming this as R1, R2, R3. R1, R2 and R3. Now how to find the proper ratio? So here which number I should multiply here so that I will be getting without fraction. So if I multiply with the 2, here it is going to be 2 by 3. If I multiply with the 3, here I will be getting 3 by 2. So I should take what? A common number, so that which can be cut with these two also. So I am taking 6. Once if we cannot take 2 and 3, 4 we cannot take, 5 we cannot take. If we say take 6, we will be getting. So I1 is to I2 is to I3 is equal to 6 is to 3 is to 2. So multiplying with the 6, I multiply with the 6, I will be getting this. and I1 plus I2 plus I3 is equal to what? 10 ampere. So this much details I have. Now we will apply our ratio. Okay, this is multiplied with the 6 and we got it. So I1 is equal to how much is the ratio? 6. So I get here 6 plus 3 plus 2 is how much? 6 plus 3 plus 2 is equal to how much? 9, 11. So 6 by 11. My ratio divided by total into the quantity that is coming, that is 10. So what we are getting here? 60 by 11. 60 by 11. Clear? I2. If I take I2, what is the ratio of I2? 3. 3 divided by total into 10. This is what? I2. I3 is for how much? The ratio is 2. 2 divided by total of the ratio 11 into its total into 10. But this is the answer. Clear? Note it down. Next question. Yes, find the current and potential drop across all the, find the current and potential drop across all resistors. Okay, find the current and potential drop across all the resistors. Okay, so here how much current will be coming? So let's find R equivalent. 3 resistances are there. So 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R equivalent is equal to 1 by 2 plus 1 by 3 plus 1 by 6. What is the LCM? LCM we will get as 6. So here it is going to be 3, here it is going to be 2, it is going to be 1. So 3 plus 3, 6. This is going to be 1 ohm. Okay, 1 by R equivalent. 1 by R equivalent is 1. So we get R equivalent as 1. R equivalent as 1. This is the direct method. This is the direct method. Now just see how to take the resistance, equivalent resistance in competitive exams without using pen paper. Okay, see, you know R is equal to R1 R2 divided by R1 plus R2. This one you know. I am using, you might be thinking without using pen and paper, right away sir has written the formula. Just for your understanding I am writing. Okay, otherwise you need not use also. Look here, R is equal to R1 R2 by R1 plus R2. Now take 6 and 3. 6 and 3. So if we use 6 into 3 by 6 plus 3 is equal to 18 divided by 9, you will be getting 2. So this combination is nothing but 2. Then 2 and 2 parallel. N resistances connected in parallel is nothing but R by N. Here 2 resistances of 2 ohm connected in parallel, R equivalent is nothing but R divided by 2. So this is 2 by 2, you will be getting 1 ohm, same as that. So without using pen and paper, how to do? 6 and 3 are very common value. 6 and 3 are very common value. 6 and 3 when it comes in parallel, immediately you should take 2. How to take? This is parallel. 6 into 3, 18. 6 plus 3, 9. 18 by 9, 2. 2 and 2 parallel, exactly half. 2 resistances, same resistance parallel, take half. So 6 into 3 by 6 plus 3, 18 by 9, 2. 2 and 2 parallel, 1 ohm. Bus. You should finish that calculation in 3 seconds. Okay. So we got the equivalent resistance. Note it down. Okay. Once if we get equivalent resistance, then we can take like a, okay, sorry, this is 4 ohm, this is 1 ohm, okay, 1 ohm, this is 4 ohm, and this is 10. So I is equal to what? I is equal to 10 by 5. This is R is equal to 4 plus 1 is equal to 5 ohm. So 10 by 5 is equal to 2 ampere. So 2 ampere will be generated from here. 2 ampere will be generated from here. So 2 ampere, it is coming 2 ampere, 2 ampere. 2 ampere reaches here, then it will have to divide. Correct? So one method which we can find directly is, if 2 ampere goes like this, V4 ohm is equal to, just by using the formula IR, this is going to be 2 into 4, this is going to be 8 volt. So from 10, 8 volt, who 8? This 4 ampere 8. How much is remaining? Only 2 volt is remaining. These are all parallel. So 2 volt, 2 volt, 2 volt. It all will be 2 volt. So the current through this is going to be 2 by 6, that is 1 by 3 ampere. Current through this is nothing but 2 by 3 ampere. Current through this is 1 ampere. This is one way of calculation. Okay, easiest way. Or otherwise, what we can do? Okay, note it down. Note the solution also. You should learn all the techniques. Then only, based in different situations, which is the apt solution, apt way you can apply. Okay. Now, suppose if you did not get this idea. Okay, you simply okay, I mean idea in the sense, if you get 2 ampere, okay, using the equivalent resistance, you got that, okay, 2 ampere is flowing, but here two ampere is flowing. This idea you got. Now okay, 1 by 3 is the answer we got. Okay, but here 8 volt, then here 2 volt. If you get that idea, okay, we will be able to answer. Suppose if we are not in a position to find this, if this resistance is not given, if you get a circuit, that resistance is not there, and using this current, you are not in a position to understand that, but this current is clear, 2 ampere is coming. Suppose if this is the question, 2 ampere is coming, this resistance is not given, then how to find? So that is what I1 is to I2 is to I3 is equal to 1 by R1 plus 1 by R2 plus 1 by R3, sorry, not plus, dot ratio. Correct? Then another is I1 plus I2 plus I3 is equal to 2 ampere. Clear or what? So if here I1 is to I2 is to I3 is equal to, if we take this as I1, this as I2 and this as I3, this is going to be 1 by 2 is to 1 by 3 is to 1 by 6. So just in the previous case, just now we have done the same kind of problem. So we will multiply with 6, we will get 3 is to 2 is to 1. Now we can find I1 is equal to 3 divided by total, 3 plus 2 plus 1. So how much is this? This is 6, 3 by 6. 3 plus 2, 5 plus 1, 6 into how much? The total current. Okay, so this is going to be 3, we will be getting 1 ampere, correct? Same way I2. I2 is equal to how much? 2. 2 divided by total, 6 into 2 ampere. Cut, this is going to be 3. 2 by 3 ampere. This is also correct. Same way I3 is equal to how, what is the ratio I3? 1. 1 divided by total, sum of all these, 6 into 2 ampere. So this is going to be 1 by 3 ampere. So this is also correct. Okay, so in this way we can find the currents. Once if we find the current, V1 is nothing but I1 into 2, V2 is I2 into 2, V3 is I3 into 3. Likewise we can find the voltage also. Okay, so what are the voltages across those? This is 2 volt IR, this is also IR 2 volt, this is also IR 2 volt. Already we have found. So you should learn all these techniques, so based on the situations we can apply all these techniques and get the answer. Next question. Find the current and potential drop across all resistances. Find the current and potential drop across all resistances, across all resistors. Okay, so how to find? Okay, so here, in order to first we need to find the current that is coming from here. So here we need to find R equivalent. So here what is R equivalent? R equivalent is 12 into 6 divided by 12 plus 6 is 18. So this is going to be 3, this is going to be 4. So R equivalent is 4 ohm. So I can replace like this is 4 ohm, when it is coming like 3 ohm. 12 and 4 parallel, 12 into 4 by 12 plus 4 is 16. So this cancel 4, this cancel, you get 3. So again this is going to be 3. So this is 10 volt, 4 ohm, this is going to be 3 ohm. So now they are all in series. So R equivalent here, it is going to be 4 plus 3 plus 3 is going to be 10 ohm. So current that is flowing, I is equal to how much? 10 by 10 is equal to 1 ampere. Okay, all these are current. This is going to be 1 ampere. 1 ampere current is flowing. Okay, now I write 1 ampere current is flowing. So now using ratio method also we can find, or otherwise we can find the current across I1 and I2. If this is I1, how to find I1? I1 is equal to 1 into opposite branch resistance, 6 divided by 12 plus 6 is equal to 18. So this is going to be 3. So 1 by 3. This is going to be 1 by 3 ampere. How much is here? I2 is equal to 1 into this branch, 12 divided by 18. So here it is going to be 2, this is going to be 3. So 2 by 3. 1 by 3 ampere, 2 by 3 ampere. So 1 by 3 into 12, how much voltage will be dropped here? 12 by 3 is going to be 4 volt. Here this is current. So V is equal to IR. So 2 by 3 into 6. This is going to be 2. So how much is this? 4 volt. I'm sorry. Already this is parallel now. So this, if we find this 4 volt, directly put here 4 volt. Again this joins here, and this is again 1 ampere. 1 ampere. So V is equal to IR. This is going to be 1 into 3 is equal to 3 volt. So the voltage here it is 3 volt. What about here? Consider this as I1, this as I2. So I1 here is, I1 is equal to the current that is coming is 1 into opposite branch current 4 divided by 12 plus 4. This is going to be 16. So this is going to be 1 by 4 ampere. So here current is 1 by 4 ampere. So this is going to be, obviously this is going to be 3 by 4 because total current is 1 ampere. So I2 is equal to 1 into this branch current 12 divided by total is 16. So here it is going to be how much? 3, and here it is going to be 4. So this is going to be 3 by 4 ampere. So 1 by 4 into 12, this is going to be 3 volt. 3 by 4 into 4, 3 by 4 into 4, 4 cancel. This is going to be again 3 volt. If we find here 3 volt, this is also going to be 3 volt. So all the branches current and all the voltages we found. Is it clear or what? So nothing. Since current is not given, first we found the equivalent resistance of this. 12 into 6 by 12 plus 6. 4 ohm we got. Here this is already 3 ohm. This one again we don't have equivalent resistance, so we found 12 into how much is this? 4. 12 into 4 by 12 plus 4. So 3. So 4, 3, 3. This is in series. Total is 10. So I is equal to V by R. I is equal to V by R. V is equal to 10 divided by equivalent. 4 plus 3 plus 3. This is again 10 by 10 we get 1 ampere. So we got 1 ampere. 1 ampere after coming here. Either you can use ratio method or otherwise you can use current division rule since two resistances are there. So we found the current here. Once if we get the current, V is equal to IR. Current through this branch also we know. Resistance also we know. V is equal to IR we can use in both. Same way there also. Ratio method also we will see here. So this was 12 ohm, this was 6 ohm, and this is 12 ohm, this is 4 ohm. This was 3 ohm. Okay, now we know 1 ampere current is coming. Ratio method is important because if we get more branches, we will be under trouble. So current division rule, 2 branches are there, current division rule is okay. Now I1 is to I2 is equal to 1 by R1 is to 1 by R2. Okay, and I1 plus I2 is equal to 1 ampere we know. So I1 is to I2. I1 is to I2 is equal to 1 by R1 I1 I2 will take. So 1 by 12 is to 1 by 6. So I1 is to I2 is equal to 1 is to 2 we get. Multiply with the 12 we will get 1 is to 2. So I1 is equal to, take this 1 divide by sum of this 3 into 1 ampere. So this is going to be 1 by 3 ampere. Same way I2 is equal to, I2 is how much? 2. The total 3 into total 1 ampere. Total is here 1 ampere. So this is going to be 2 by 3 ampere. Same way we can write. This one I1 is to I2. If this is R1, this is R2. I1, this is I2 if we take. Okay, so 1 by R1, 1 by 12 is to 1 by 4. So I1 is to I2 will become 12 by 12, 1. 12 we will multiply with the 12, we get 3. So I1 is equal to 1 divided by, this is 1, divided by total 4 into 1 ampere. So we get 1 by 4 ampere. I2 is equal to, I2 how much ratio? 3. Total of this is 4 into 1 ampere total current is coming. So 3 by 4 ampere. So all these are methods. Next question is to find the equivalent resistance between A and B. Okay, when you get two terminals, between two terminals, when you look from these two terminals, what is the equivalent resistance? Okay, try for yourself, take some time and try. So in this question we have to approach from this end. So if a current passes through a branch, if the same current passes through two resistances, then they are in series. If a current I, see, if a current I passes like this, definitely this is going to divide into I1, I2 and I3. So these I1, I2, I3 are not in series. But this I1 when it comes, so here I1, here also I1. So 2 and 4 are in series. Okay, so if you want to understand the steps, you have to draw again and again. If you are comfortable, no problem. So what I am going to do, I am making this into a single resistance. Okay, single resistance. So now what was the resistances? 2 and 4. So that 2 and 4 are now, 2 and 4 are now what? 6 ohm. So I replace this into 6 ohm resistance with the 2 and. So now I1 is coming like this, for example I1. I2 is coming like this. So we can see that from here I1 and I2 is divided, and here I1 and I2 are joining, and this will be flowing like this. So these two are parallel. See, look at these two nodes. This is like this. Same way, R1, R2, this is how these things are. Only shapes are different. So 6 into 3 by 6 plus 3, already we have seen this in the previous problem. I told you 6 and 3 comes parallel, then it's immediately you should understand that this is 2. No need to calculate every time. Throughout the year 6 into 3 by 6 plus 3, don't do that like that. 6 into 3 by 6 plus 3 is 2. So hereafter till you clear the exams, at least till you clear the exams, you should have this in memory. 6-3 parallel combination gives 2 ohm. So what I am going to do is I will make this into 2 ohm and I will be connecting this as a single resistance. Okay, so these two we will combine. Okay, we will combine and we will make it into a single resistance. Okay, I will make it into a single resistance parallel. What that is? 2 ohm. So this was like this actually. This is how it was. From here it was like this was like that. Okay, this one is parallel 6 and 3. So what we did across this junction we made it into 2 ohm. Now this 2 and 4 are in series. That is again what? 6 ohm. So this is 3 ohm, this is 2 ohm. Now this 2 and 4 are in series, so we will replace that with 6 ohm. Now this 6 and 3 are what? Parallel again. They are in parallel. That is nothing but 2 ohm. So this 2 ohm, this 3 and 6 are in parallel. 3 and 6 combination is 2 ohm. Already this 2 ohm is there. This will become one single branch, that is here A, B. Now this combination gives us 4 ohm. So equivalent resistance between A and B is what? 4 ohm. Clear? So we started from the other end, started from one end, series, parallel, likewise we deducted into a single resistance. Okay, so we have done some problems on resistances. So after next lecture also will be based on to find the equivalent resistances. Some complex circuits we will take, and we started with the basic circuits. Revise all these combinations which we have tried today, and try to do some extra questions also, and make yourself fully engaged with the electrical circuit. So if you continue like that, if you maintain consistency, if you daily study this, then things will be easy for you. Whichever circuit you get, you will be able to solve it in no time. Okay, this is very easy chapter, easy topic, this circuit theory. Once if we understand how to apply various techniques we study in the class. Okay, students, goodbye, good luck.